Good morning, class. We are looking at Math 119A, Biocalculus, Chapter 1.6 to 5.4 review. This is the final exam review, the first part. Differentiation formulas from basic to trigonometric functions to chain rule, delta y versus dy, linearization, which refers to finding the tangent line. Logs, notice log x base b equals y means follow the arrow b to the power of y equals x, which means b, the base must be positive, can't be 1, results in the following properties we should be comfortable with. If the base is 10, log base 10 of x, we don't write the base, we call it common log. These are the properties. When the base is e, we write ln x, and these are the properties. Exponential and logarithmics are inverse functions, therefore symmetric with respect to line y equals x. Change of base formula. And I want you to notice this means this point. Okay. And to the left of that, log is negative, to the right of it, positive. Natural log, the derivative is 1 over x. If it's g of x, ln of g of x, 1 over g of x times g prime of x. And if the base is other than base e, notice this says ln x over ln b, so we tag along 1 over ln. The reverse process gives us integration or anti-differentiation, and these are various formulas for that. FTC, short for fundamental theorem of calculus. ddx of the integral of a to power a, the integral of a to x f of t dt is f of x. In other words, take the integral and then differentiate it, becomes the same function. And the integral of a to b f of x dx is capital F of b minus f of a. This is called a definite integral, which is a number. Substitution rule, which is the reverse process of the chain. And now we're going to differentiate this. And by the way, you have all of this given to you. All you have to do, just pay attention so everything comes back to you in case you don't have to write anything. So first, this one is to the power of 1/2. Bring it up, make it negative 1/2, and therefore get it ready for the power rule. So 4 times negative 1/2. Same thing to the power of negative 1/2 minus 1, which is negative 3/2. The derivative of the inside, 2x. The product of these two, negative 2 with this one becomes negative 4x. You take this one down, make it positive 3/2, or the square root of x squared plus 3 quantity cubed. This one also uses the extended power rule. First we use 5, then the same thing to the power of 4. And then now this part uses the quotient rule. Let's say this is f over g. So f prime, which is 2 times g, which is x minus 8, minus g prime, which is 1 times 2x plus 3, over the bottom, which is x minus 8 squared. 2 times x, 2x, minus 16, minus 2x, minus 3, and we cancel these two. Is to add up to negative 19. To make sure everybody understands what we are dealing with, we are going to rewrite this one as 2x plus 3 to the power 4 over x minus 8 to the power 4. And this one, of course, we just write it. Now 5 times negative 19, negative 95, 2x plus 3 to the power 4. And these two, when you multiply them, x minus 8 to the power 4 plus 2. And that's the final answer. Differentiate implicitly, we put a raised dot because it uses the product rule on this. Let's call it f times g. So we use the product rule on that f prime g plus g prime f. So 4x squared, 8x times y plus y gives you y prime or dy dx times 4x squared. 2y squared, the extended power rule, just like this one, 4y prime, any number, including e, results in 0. We put these two together and remove this one. When we put those two together, we take out the common factor of 4y prime because we want to solve for y prime. We're going to divide by 4 times x squared plus y. And the final answer is negative 2xy over x squared plus y. Differentiate cosine 3t to the power of 4, as I have mentioned this many times before. When you want to differentiate sinusoidal functions, read and pause. Cosine. You should know the derivative of cosine is negative sine, so negative sine. But negative sine of what? In essence, you're looking at g of x, so the same argument must be used, and then g prime of x. In this case, the derivative of this one, g prime of t in essence, which is 12t cubed, and you put that in front, the final answer would be negative 12t cubed sine of 3t to the power of 4. A related rate problem, an application problem, a word problem. A small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So we are dealing with a circular shape. From the center to the circle, this distance is the radius. And if you go both sides, it's the diameters, where d is 2 times r. Circumference, if you go around it, is 2 pi r, and the area is pi r squared. And that's what we need for this question. So we need all of those. We need to know all of those. The one we are using, a equals pi r squared. We are going to reread and write the given in symbolic format. So the radius is increasing at this rate. The moment you hear rate, it means differentiation. So the RDT is 3/2 feet per second. What are we looking for? The ADT, the rate at which the area is changing. At what point? When R is 4 feet. So A equals pi r squared is a piece of information from prior knowledge of mathematics we write down, and the rest is written symbolically to make it easier to finish the job. So A equals pi r squared, we want the ADT. And again, reminding you dy dt is dy du du dt according to the Leibniz's notation. So pi is a number, is a coefficient, is a multiplier. It remains. You're working on r squared, which gives you 2r dr dt, or 2 pi r dr dt. Replace the r with 4 feet dr dt with 3/2. Please understand, when you're replacing them, in essence, 4 means 4 feet, 3/2 means 3/2 feet per second, and the units of area over the units of time, square feet per second, would be the final units in this case. 2 cancels out the 2, 3 times 4, 12 pi. That's an exact answer, everybody. This is an approximation. Always go with the exact answer. If they ask you for the approximation, so be it. You put down the approximation as well. Find dy dt for the equation 5x plus y to the power of 4 minus x equals 6. Well, 4 times 5x plus y cubed times the derivative of the inside. Dy dt indicates that t is the independent variable. So 5x, the derivative is 5 dx dt, y is dy dt, and minus x is minus dx dt. Any number results in 0. We can solve for dy dt, but there is no reason, just plug in for this. So when we plug in, This is 1, cubed is still 1. This product gives you 60. These two add up to 57. You move it, you make a negative, divide by 4, and that's your final answer. dy dt becomes minus 57 over 4. A 20-foot ladder leans against a building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. You really should read application problems a number of times to be on the safe side. So a 20-foot ladder leans against a building. So here's the building or the wall, and here's the ladder. The base is going away at a rate of 2 feet per minute. So dx, it creates a speed or rate. Dx dt is 2 feet per minute. As it moves this way, it creates the shape, which is a right triangle. As it comes down, this gives us a speed or rate dy dt, which we don't have, and we are looking for that. This ladder is fixed at 20 feet. We call it C because it follows Pythagorean theorem a squared plus b squared equals c squared. So we're going to say x squared plus y squared equals 20 squared. Define your variables. And so we want dy dt at what point? When the base x is 12 feet. So you write this symbolically. One more time. Dx dt is 2 feet per minute. This comes from Pythagorean theorem. X squared plus y squared is 20 squared, which is 400. Dy dt is of interest to us at a precise moment when x is 12. So differentiate this with respect to t, 2x dx dt plus 2y dy dt equals 0. You have everything except y. So how do you find y? X is 12. X is 12. If you plug in, you can find y. So 12 squared plus y squared is 20 squared. This is 144. This is 400. We're going to move this, make it negative. The result is 256. And the square root of that is 16 feet. Now we have everything. We plug in. 2 times 12 times 2 is 48. 2 times 16 is 32. Move the 4dx and make it negative. Divide both sides by 32. Both numbers are divisible by 16. Negative 3 halves feet per minute. Again, obviously x is increasing. Dx dt must be positive because y is getting smaller, is decreasing. Dy dt must be negative, and it is. How do we find limits? Well, we plug in and observe. What happens? It gives us a number. We're done. It gives us a 0 over a number. By that, we mean a number other than 0, and the answer is 0. It gives us a number over 0. We have to figure out if it's infinity or negative infinity. We used to say it's undefined, but now in calculus, infinity or negative infinity. Indeterminate form of 0 over 0, infinity over infinity, infinity minus infinity, and there are other forms. We need to use our algebraic techniques to get to the answer. Right here, for example, if you plug in I hope you recognize x is approaching infinity, the top becomes infinity, the bottom becomes infinity. So what is the technique? The technique when x is approaching infinity is to divide by highest degree in the denominator, which is x squared. So we're going to divide everything by x squared. This becomes 2, this becomes 1, this becomes plus 8 over x, this becomes minus 16 over x squared. Because x is approaching infinity, 8 over x and 16 over x squared, each one goes to 0, the answer is 2 over 102. However, anytime you're dealing with a rational expression or a fractional expression, the very first step is to simplify if you can. I hope you recognize the top. We can factor the 2x out, we get 2x times x plus 4, and the bottom is a squared minus b squared. Therefore, x plus 4x minus 4. And so I can drop the common factor of x plus 4. And now we should work on that. In this case, really doesn't make much of a difference. If you work on it, now you divide by x. This becomes 2, this becomes 1, and this is minus 4 over x that goes to 0 because x is approaching infinity. So it gives you the same answer. Over here, if you plug in, you get 0 over 0, and the technique is to factor. We already have factored it. So now, if I put negative 4, I get negative 8 up here. I put negative 4, I get negative 8 down here. The answer is 1. So factored format will do the job for us. Otherwise, it won't. In this case, if you plug in, actually, it happened to work just the way it is. If you plug in, you get 0 over minus 16, which is 0. But working with the factored format also will give you 0 over minus 4, which is 0. So doesn't make any difference. However, what happens in these cases, if you plug in the 4, let's go with 4, you get 0 in the denominator, and it is easier to work with the factored format. So we're going to work with the factored format because it's easier. And if I plug in 4, in both cases, I get 8 over 0. However, why is it important to pay attention to this? Class, if you plug in 4 and you get 0, 0 is the only number that the left side is negative and the right side is positive. Any other number, both sides are the same. So first, for example, if I put, let me see if I have room here. If I put a positive number, let's say 2, the left side and the right side of 2 are positive. That means the left side is like 1.9, the right side is 2.1. If I put negative 8, both sides are negative. You see that? So it's only 0. And because of that, you have to put in. So what do you put in? 4 from the left, like that means 3.9999. Let's say you can even put 3 because you want the sign, but 3.9 minus 4 is negative 0.1. So you put 8 over 0 from the left. And remember, a number divided by 0 ends up being infinity, but the sign says negative infinity. On the other hand, this guy, like 4.1 minus 4 is positive 0.1. And by the way, the numerator in both cases is 8, class. This one is like 7.9999. This is like 8.0001. Both of them are very close to 8, so it makes no difference. This one, 0 from the right in the denominator, results in positive infinity. And that's the idea that you want to be very careful. All right, how about this one? 12 over 4 plus 3 e to the power minus t. All you have to do, plug in, you get e to the power of minus infinity. So reminding everybody that a to the power of minus m is 1 over a to the power of n. E to the power of minus t is 1 over e to the power of t. And therefore, e to the power of minus infinity is 1 over e to the power of infinity, which is 0. And so we end up with 12 over 4 over 3. Over here, if you plug in infinity, you get e to the power of infinity, which is infinity. And by the way, everybody, 3 times infinity or 10,000 times infinity or infinity divided by 10,000 is still infinity. The only thing is if it happened to be negative, makes it negative. So and again, it doesn't make any difference. 12 over infinity or negative infinity is 0. This one, I hope you recognize this was t approaching infinity, e to the power minus t. This is t is approaching negative infinity. So if you plug in, you get e to the power minus infinity here, which is again the same 0. And so the same answer as part A. What happens in part D, you plug in 0. And you should know e to the power of 0 is 1, so 12 over 7 is the final answer. We want to differentiate this. We're going to bring this up to get it ready to use the extended power rule. 12 times negative 1. Same thing to the power of negative 2. We are using the extended power rule. Now the derivative of the inside is 3 to the power of t. And we're done. So this one goes down, becomes positive exponent. 12 and negative 1 and 3 to the power of t. Their product is negative 36 e to the power of t. If you plug in, all of them will give you 0 over 0. The technique in this case is factoring. And because x is approaching 5, it should have a factor of x minus 5, and it does. The numerator is x plus 5, x minus 5. The bottom is x times x minus 5. And now, if you plug in 5, you get 10 over 5, which is 2. Part B, if you plug in, you get 0 over 0, and the technique is LCD, which is 4x. So we're going to multiply and divide by 4x. Remember, this is 1 and it's okay. For the denominator, x approaching negative 4, making this 0. That's why you never, ever distribute. You keep it as a product. And this one, when you distribute, you get x plus 4. And you were hoping that actually the denominator goes away, and it does. So this cancels out this one. You get 1 over 4x, or negative 1 over 16 is the final answer. For the last part, if you plug in, you get 0 over 0. And the technique is the conjugate. A plus b and a minus b are conjugate. Therefore, when you multiply those two, you get the first one, square root of 1 plus h squared, minus the second one, squared. And so the denominator, we keep it as a product, and the numerator becomes 1 plus h minus 1. 1 and negative 1 cancel each other. H and h cancel each other. And now, if you plug in 0, you get square root of 1, which is 1. With 1 becomes 2. The final answer is 1/2, and you're done. How about this one? If you plug in, you get infinity over negative infinity. Now, because this is a fractional format and t is approaching infinity, you are going to use the same technique with rational functions. You divide by highest value in the denominator, which is e to the power of t. When you do that, this is 5 over e to the power of t, this is 4 over e to the power of t, they don't change, but this becomes 1, this becomes negative 3. When t approaches infinity, each one of these goes to 0, so positive 1 over negative 3. The final answer is negative 1/3. What about e to the power of 2x ln x? We want to differentiate. We put a raised dot and we say, okay, it's going to use the product rule, everybody. So the derivative of e to the power of 2x is itself times 2. This is f prime g ln x plus g prime. The derivative of ln x is 1 over x times f e to the power of 2x. So what we are looking at is f prime g plus g prime f. Take out the common factor of e to the power of 2x, and the final answer is e to the power of 2x times 2 ln x plus 1 over x. What about this one? The very first step is to simplify, to decompose the log. There is nothing to do. Therefore, flip this over, 1 over x squared plus 1. Times its derivative. So 1 over f of x, and now times its derivative is 2x. Now, is the base e? No. So 1 over ln b, 1 over ln 5. And just rewrite this. As you can see, 2x is the only one for the numerator. These two belong to the denominator. What about this one? Well, you want to decompose the log. That goes a lot faster. So natural log of the top 2x minus natural log of the bottom 2x plus 1. I'm looking at number 6, everybody. And then ln of 2x. So let's write that actually. So we have ln of the top 2x minus ln of the bottom 2x plus 1. And ln of the top 2x can use number 5, the product rule, and become ln2 plus ln x. And this is completely decomposed, make it very easy to finish the job. ln2 is a number 1, ln x is 1 over x, minus 1 over 2x plus 1 times 2. We're done with calculus. X times 2x plus 1 is the common denominator. And so 1 times 2x plus 1 minus 2 times x. Obviously, these two cancel each other. 1 is the numerator, so 1 over x times 2x plus 1 is the final answer. Final equation of a tangent. Well, we need two things. We need the slope, so we're going to differentiate 2x minus 3. The slope is plug in 4. So 4 times 2, 8 minus 3, 5. We need the pair, plug in 4 into the original function f of 4. So if I put here 4 squared, 16, minus 3 times 4, minus 12 is 4, minus 1 is 3. And now, y minus y1 equals m times x minus x of 1. And 5x minus 20. Move this. 5x minus y equals 5x minus 17 is the final answer. A doctor prescribes a 300 milligram drug to be taken every 12 hours. Just before each tablet is taken, 40% of the previous amount of the drug remains in the body. Write the expression for Q sub n plus 1 in terms of Q sub n. So first and foremost, these are the formulas. We are dealing with a prescription drug, and generally speaking, it starts with 0. And B, by the way, changes to Q because we are using Q here. So B sub 0 or A In this case, Q sub 0 is 0 because we want to write the given. 300 milligrams of drug to be taken every 12 hours. That means you give it to them again and again and again after 12 hours. So that is the amount of constant, everybody. Lowercase c. What is R? The percentage that remains in the body. R is 0.4 for this question. If they said a percentage is absorbed, you have to subtract it from 1. You don't want to mix them up. Therefore, we're going to write this formula and change the B to Q. And now we use the given, replace the R, replace the lowercase c, Q sub n plus 1 is 0.4, Q sub n plus 300 is the final answer. To find Q sub n, we're going to write this formula and change the B to Q. Go back to the given, replace it. 0 times any number is 0 in this case, so we are going to say this is 0. This is obviously 0.6. So 300 divided by 0.6 is the same as 3,000 divided by 6 or 500. The fifth tablet, how much drug is left after the fifth one? You replace the n, put it into a calculator. 494.88 milligrams would be the answer. What about the limit? Let's take a limit. And reminding everybody this goes to 0. And here's the reason. I hope you remember. When we have r to the power of n and n goes to infinity, if r is between -1 and 1 goes to 0. If this goes to 0, the answer is 500 times 1 or 500 milligrams, which means if you keep on doing this forever and ever and ever, as long as you follow this every 12 hours, it will never go over 500. And that's the importance of the 12 hours that has been calculated previously. But it doesn't enter any of the formulas here. F of x is 4 e to the power of -0.2x minus sine x. I want to differentiate and integrate. The reason I want to do that, because exponential and sinusoidal functions, sometimes students mix them up. So in the case of a differentiation and integration, exponential is itself. So we have the same answer. But in the case of a differentiation, we multiply by -0.2. Integration, we divide by it. So we're going to write the same thing times -0.2. And the derivative of sine is cosine. So this keeps the sign negative. Okay, so negatives. So this is -0.8 e to the power minus 0.2x minus cosine x, and we're done. As far as integration, we're going to write this with the dx first. And as I mentioned, the derivative and the integral are the same, but this one, we're going to divide by 0.2 minus the derivative of sine is cosine, but the integral is negative cosine. With this, negative becomes positive, and of course, we have a constant. This is the same as 40 over -2, which is -20, and that's the final answer. What if capital F of 0 is 20? Well, we are making it, this is the general solution, we are making it into a initial value problem. So let's plug in. When we plug in, this is 1. So we get -20 plus cosine of 0 is 1. So we get -19, moves to the other side, plus 19, C becomes 39. And this is a general solution. And it's a particular solution. With one pair, we can find the C. This is a family of functions. All right, we're going to do several steps of algebra. This is x to the power of 1/2. Make up two fractions. This has the exponent 1. 1 minus 1/2 is 1/2. So x to the power of 1/2 plus x to the power minus 1/2. All we've done is getting it ready to use the power rule. 1 over 1/2 plus 1 x to the power of 1/2 plus 1 plus 1 over negative 1/2 plus 1 x to the power of negative 1/2 plus 1 and a constant. 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is 1/2. The reciprocal of this is 2/3. This one is 2. And we're done. When you are using substitution and you're dealing with polynomial functions, the more complicated one, in this case, x squared plus 5, is the choice of you. As you know, its derivative, the u dx is 2x, which makes the u is 2x dx. So move the 2x next to dx so it becomes clear this is u, this is du, so you're dealing with u cubed, which means you're dealing with the power rule. So 1/4 u to the power of 4 and a constant. Reverse substitution, 1/4 x squared plus 5 to the power of 4 plus a constant. What happens when you're dealing with fractions? Step 1, simplify if you can. Step 2, if you cannot, the denominator is a choice of u. Notice its derivative is e to the power of t, therefore du is e to the power of t dt, and dt always belongs to the numerator. Rewrite it, and notice the integral of 1 over x dx is natural log, so the same thing here, natural log of u and a constant, and substitute, and you're done. What about this one? The first step is to simplify the denominator and factor the denominator and simplify if you can. The denominator can't be factored. Why not? Recall the quadratic formula is ax squared plus bx plus c equal to 0. X is minus b plus minus the square root of b squared minus 4ac over 2a, where b squared minus 4ac is called the discriminant. If it's positive, we have two distinct real solutions. One, if it's equal to 0, one real solution. If it's negative, no real solutions or two complex solutions. One more piece of information. If b squared minus 4ac is a perfect square, then we can factor it. If you look at this one, a is 1, b is 2, c is negative 1, and b squared minus 4ac is 2 squared minus 4 times a, which is 1, c, which is negative 1, and it's 8. 8 is not a perfect square. We can't factor it. Therefore, the denominator is a choice of you. Its derivative is 2x plus 2, or 2 times x plus 1, which makes du 2 times x plus 1 dx. We put the dx at top, and notice 2 is missing. Remember the method that most books do. They solve for dx. The method that I do, if a number is missing, I put the number and its reciprocal. And now this part becomes just like this one, which is a natural log. And reverse substitution, half of ln of absolute value of x squared plus 2x minus 1 on a constant. Now, you could, you have to keep the absolute value here. You could drop the absolute value and change it to parentheses because the expression is positive. That's up to you. If you have the reciprocal of this one, you have to do long division or synthetic division. If you have the reciprocal of this one, you make up two fractions. This one and this one. This, the integral is minus 5 e to the power minus t. This is t and a constant, and you're done.